Good morning, folks. Perfect. We are live. Got a couple big goals today. Goal number one is to figure out the whole environment mess. What's up with our vectorization? Goal number two is to refactor. I forgot to grab one thing, and we will get started right away. All right. Right, so if I recall what was happening last time, we had this really weird performance disparity. Oops. Go away, Claude. Okay, so here's the OMP performance with breakout, and then there's a different test. So this one? No. Breakout. I think this one. Right, so this was the disparity. Because this is pretty much the same code, right? We have this chunk here. See if that changes it. Ah, it does. It does. Okay. Interesting. So it's a very, very minor little difference, as it turns out, with just the way actions are being computed. Let's go double check this. Right. So, and now it goes back up in perf. Okay. So that's all it was. It was just like this very, very minor little quirk. Cool. We should be able to go from here. Yeah, let's just go with no action being added. And actually, do I want to try to fill? No, I think that it's fine. We'll use this as a test. Yeah, and we'll leave this like this. So, the next thing we need to do now is go revisit some of the tests. Breakout, single. Right, because it was with multi-threaded is the test from before, and this is quite fine performance. So we do OMP direct, 8192 M's and 8, and the goal is to get this to match. Back, breakout. Okay. Well, we have this thing passing anyways, right? Two. Okay, it's opening some weird DLL. Let's figure out why it's doing that. Yeah, I went through this way too quick yesterday. Hello, good morning. What are we working on today? So we're going to fix up the M speed test, I think. And then we're going to work on cleaning up Puffer for pre-alpha. Okay, so this direct test here gets a 71 mil, which is pretty close. 80 mil from the native file. Let's go take a quick look. That's pretty close. And then if we go to profile, OMP, what do we get? Can you tell me what I'm working on? So, two things today. The first one is fixing up and having a good understanding of the performance of our vectorization. And the second one is a large general cleanup of Puffer so that we can get this thing, so we can get you all playing with it, essentially. So it's clean enough to play around with it for pre-alpha. Those are the two main goals of the day. Well, okay, so this is just calling random crap. Right? This barrier thing sucks. Oops. So we now know the target's actually like 80 mil. And yeah, that's nowhere close. So presumably I've just made a mess of this and I have no idea what's even getting called anymore. Great example of exactly what not to do. Profile vec OMP step. Vec OMP step. Yep, so exactly this thing is a mess. Let me see if I remember what mess, because I'll just have it undo it. Or was it just, I let it make a mess. It's stupid. I need this flag. Other than that, I think this might be irreparable. We might have to just stash and reset. And just take the knowledge, essentially. Okay, so this is still reasonable here, right? Let's see what this gives us. Oh, wait, hang on. One other thing I think I forgot. Got CPU. Do you have any, oh, hang on. Do you have any idea where I can start an RL? I'm a BTech student. Yeah, I got you. Hang on. I have a guide. Let me put this chat where I can see it more easily. if you're new to RL, the place to start is right here. Engagement CS researcher app in some project which will help others. It depends if you want, like, how deep you want to get into research. This guide will give you starting points for both of those, though. It's like, I spent quite a while on this. This is going to give you a much better answer than I can give you just off the cuff here. This is pretty much like a step-by-step on how to get into RL and how to start thinking about research. Okay, so this is 54 mil. Yo, good luck. Thank you. Oops. Right, so the one flag I did remember helping, or was this flag? I think it was like no semantic something or other. Get a sub? Sure thing. I mean, this is all open source work as well. I run probably the largest, no, I think definitely now the largest RL dev community open source. We also write the highest performance software in the field. So if you're interested in learning, I mean, we have a ton of people around that came in with no RL experience, no AI experience even, and are now doing some pretty awesome stuff. So it can be done. It does take some work, but the one thing I can promise you is that the way we do stuff around here, you will learn a lot more directly from the stuff you do. There's a lot less bullshitting around than there is in most coursework or like more traditional stuff. I mean, I have that too if you want it, but mostly this. Hey, Linky. Okay. So I think there's a combination of two different things going on here. I think what happened, first of all, I screwed up the test because I didn't realize that there was a huge difference if you set the actions or not in the M speed. And then the second thing is compiler shenanigans. $57 mil. We're still leaking perf. If I reduce the number of M's, no. Okay, I was testing if there's like some caching breakpoint, but no. Did we get any perf out of this? Oh, we did get maybe we got a little bit. It's hard to say. Oops. Also, we don't have this on the ocean one anyways, do we? But this is for DLLs. Okay. So let's now do, what is it, the minimal test? Test barrier standalone. No, this is not the one. Speed static. Yeah, this one. Breakout minimal. This is what we want. So we want something that just loads the thing and runs the test, and then we see what we get from that. Build minimal. Okay. $81 mil. So this is what we want. This is behind the DLL. I can't type today. I don't know what's wrong. Okay, so this is what we have to work with. Error limit F open MP. We should see if it's compiler crap. Here. Now I can actually get it to do this from here. Most likely. Which test do we have? Cool. Good morning. I want to create a large 10,000 plus agent environment in 2D with continuous coordinates and continuous movement actions. Do you have any pointers? Yeah, I got you. Here. Easy. 10K is a lot though, man. I would do 8192. That's going to saturate batch size. If you really want to do it, you can do, I'd do 2 copies, like 2 environments with 8192 each, 2 instances. That's going to be more hardware efficient. You can do 1 environment in 16K if you really want. I don't recommend it though. So this is like one of the environments we have with a ton of agents. This is the convert environment. It's very simple. It's only a few hundred lines of code if you want to look at it. It's just a bunch of agents that are observing like the nearest targets and a couple other things, and then they school in this really cool pattern. And this trains in a few seconds. It's really fast. The only reason I train it with more agents than this as well. I'm limiting the number of agents that you're seeing here because it's deployed on web with a really inefficient CPU neural net. Like I wrote the neural net for this for the browser. It's really slow. But you can scale this to thousands very easily. The one thing that the pointer for you is you want to avoid anything quadratic with that many agents. Easiest way to do that is to just put agents into chunks. Oh yeah, multi-agent interactions will work. The big thing is you're going to need to do chunks or something though, because you cannot have quadratic checks over 16K agents. You can get away being lazy with quadratic up to a few hundred agents and still have it be fast, because C is fast. After that, at the very minimum, you partition the map into chunks, and then you make sure that your game is not, or your environment is not such that all the agents bunch up in one spot. That way you only have to check, agents in the same chunk or agents in adjacent chunks at the most. Much faster. Oh, this is dumb. Yeah, this is super, super dumb. Okay. We'll leave alone dumb Claude. We'll do our own stuff now. We'll give it a try. Oh, yeah. If you make anything cool and it's not private, consider PRing. So many cool projects out there to be done, and a lot of them end up being useful for research. I'm trying to think how we test this. I think the easiest way that we test this, right, is we just do, we do like one buffer. Yeah, let's just not be stupid lazy here. So instead of having this barrier crap and all this, like, what is this, man? I mean, really, we just need this. It's kind of funny, I've created the perfect example of why not to overuse Claude in the process of literally doing throwaway crap. I actually think that it is going to just be better to do this. Because now I don't have to deal with all of its crap. And we mostly have the stuff we need from it anyways. There, now I'm back to dealing with my own stuff. one thing I did want, though, was because I think I wrote that test, right? Damn it. Great example of what exactly not to do. Dummy. Why did I do that? Why did I do that? Whatever. This is the chunk that I need. There. That's all we wanted, right? Is it just export? Yeah, export void. All right. Create mspeed args, blah, blah, blah. So now we can just do profile, was it profile min profile and speed. Env name total agents. Threads. mspeed total agents. mspeed total agents, numBuffers 1, numThread 0. Horizon doesn't matter. Use GP as false. No, yeah, that's good. Okay. Okay, that's going to be the same. Then this is the correct warm-up. Very nice. Elapsed. Where's start time? Float start time. Start time. total agents. Steps. All right. There. P minimal vec step. Vec step direct. I'm trying to like, I'm futzing with a bunch of crap here. It'll all get clearer in a second. I'm futzing with like a whole bunch of crap here though, essentially, because I made a mess by overusing Claude, trying to like just figure out, I was trying to root cause something, and I left the code in a weird state. So basically I need to remove all the stuff that Claude did anyways, but there's one last test I need before I can do that. So if it was not clear, yes, these models are incredibly stupid. There we go. OMP. FM. Working on RL. Yep, that's all I stream. We build the highest performance reinforcement learning tools out there. Pretty much everything except LLMs. We're also not big into super high dim continuous control, though that's mostly not wanting to get too applied on that specific topic. What did I do? I just like mistyped everything today, right? Okay, cool. Undeclared OMP minimal vec step. So yeah, this is use the profile version. Yes, this one's not even needed. Good. Causal interface. Causal inferencing. That's broad. What exactly? 16-year-old and 11th, learning both CS and AI, like ML. Any suggestions how to advance learning Python with it? Yes, I have all of my best advice in one place for you. Here. I wrote this article like this is pretty much all my best advice, and if I'd actually listened to this when I started, it would have saved me thousands of hours. It's not like a step-by-step on how to learn programming in general, but it has all my best advice. This one is a step-by-step guide, but it's for RL specifically. But hey, RL is cool because you can actually, at least now with Puffer, you can do it at home. You can train models at millions of steps per second on a decent laptop. Double machine learning difference? No. Is this like second order Optim stuff? What? I'm not sure what this is. Double M. Is that a thing? Treatment effects. No, yeah, this is outside of my area, man. I've not seen this stuff. It's more than I can just like read up on in 30 seconds. Okay. Breakout. OMP. Minimal. 8192 agents. 8 threads. Vibe coding. Do not do that, dude. You will not learn. It'll feel really cool because you'll be able to build stuff fast, but you will not learn stuff. You can use the models. It's very tempting to over-rely on. In fact, what I'm dealing with right here is because I over-relied on a model, even for like throwaway tests, and I let it screw some stuff up just trying to diagnose a problem. And that's somebody with like 15 years of experience who should really know better and who actually, like, I actually know what I'm doing independent of these models. I'm not going to say don't use them at all, but my advice around that is in that article. You really, really want to learn stuff at a very low level. Not like the go take a course. That's not actually a lot of the information you need, but you do need to be able to build stuff end to end and know exactly what's going on. And models take you away from that most of the time. Given treatment variable affects the outcome. A lot of research almost cannot solve it. Yeah. It's pretty far off. The stuff I work on, Zanch, is I do ultra high performance simulation, like sims that run at millions of steps per second. And then I make models on the scale of a few hundred, like 100,000 to a few million parameters, train at millions of steps per second. And with RL and enough data, that's actually enough to solve very hard problems. And it's completely unoptimized. The algorithms behind it are very brittle because mostly the code is very slow. So it's like a very heavy engineering heavy area at the moment where there's a huge opportunity for progress just simply because it's an area where stuff was running literally 1,000 times slower than it should have. Or more. 10,000 in some places. So I build really high performance tools for RL. I do algorithmic research around them. It's all open source. And I stream all of it. Coding later, math first. I actually think there's pretty minimal math that you need for ML. Like the stuff you're doing is probably different, but you just need to have, you need to know multivariate derivatives. Pretty much just the chain rule, because that's the core of all of AutoGrad. My own stats background sucks. I think the vast majority of ML can be understood through either stats or through linear algebra. Linear algebra has always been easier for me. And for the most part, it's not even like the math department's version of linear algebra. It's just a bunch of tensor operations. Can you increase the volume of the mic a tiny bit? Yeah. Try that, and let me move it a little closer. It gets stuck behind my monitor. There. We'll try that. See if that's a little better. Ooh, okay, this is weird. So this being slow is very bad. So this essentially tells us there's a compilation issue, right? RTX 5080. One space. 5080 is plenty for RL. You can train millions of steps per second on that. Hey, Antonio. That's the other fun thing is we do not need Blackwell chips for RL because we don't need the memory. Our models are tiny. Very powerful though. Like it's not just a toy. It's one of the few areas you can do like really meaningful research without needing to scale models a ton. You do scale data. We train on more data than all of OpenAI, and we can do it on one GPU. Hello, what are you doing? This is my daily, or at least most of the time, most days stream. I develop high performance RL live. We are currently, what I'm doing right at the moment is I am diagnosing an issue in which we have our multiprocessing implementation for different environments. It's working well on the standalone test, but then when I compile it as part of the whole build, it's not as fast as it should be. I'm trying to figure out why. Oh, in layman terms, I'm not much of a coder. The really layman's version of this is I make AI that trains on games really, really fast, like millions of times faster than normal. And the algorithms are really general, and a lot of problems look like games. So the stuff I do ends up working on control problems in robotics. It ends up working on markets. It ends up working on a wide range of applications. And I am a researcher. I've been working on this stuff for a decade, and I stream all of my dev live. Just a quick version for sleepy Thursday morning. That's fine. Any of Josh Starman's? No. You're probably already. Yeah. I don't really go through much ML content like that anymore, man. Um, I kind of have my own stuff at this point. And also, I do produce a little bit of educational content, but it's kind of as a byproduct. Like just the way that I build stuff, I focus a lot on simplicity, speed and simplicity. So it just ends up being the case that a lot of what I do is very accessible to people, and people like to learn off of it. But that wasn't even the objective when I started this. It was more of just like a watch cutting edge research being done live and chat about it kind of a thing. It's a cool idea to streaming work. Yeah, and I don't actually lose any productivity because any time that I lose talking to chat on stream is time that I would just normally lose spacing out if I were not streaming. So I actually find it's a nice way to focus my thoughts, and I enjoy work more doing it. You work for any corporate? I have my own company. So Puffer is a fully open source, but it's also a private lab, and we build high performance simulators for other companies, for clients on request, and we integrate our RL tools with those in order to train agents. Are there free modules to use on Puffer? Everything is free in Puffer. Literally everything is Puffer, and Puffer is free. Orange data mining. I don't orange data mining. Fine. Hire me. We do hire, it's all contracting based at the moment. We do pick people for contracts though out of the contributors. There is quite a high bar, but we do pull people from the contributors for contracting work. That's what I like about open source. It's just pure meritocracy. Oops. Just bored with Amazon. Ah, yeah. I did an internship there. It was very boring. Yeah. I don't know. With the type of stuff I'm doing at the moment, it's very difficult for me to make full-time stuff reasonable because as soon as I hire people full-time, I have to guarantee a steady stream of work, right? So I have to pay people less in order to offset the times in which there will not be as many contracts. Whereas when I do everything via contracting, I just get to split stuff 50-50 with people and nobody's ever mad about a 50-50 split. It's very fair. Happy focus coding. Thank you. Free coding for beginners. I'm not an educator like that though, and I have some advice for beginners, but most of my stuff is directed towards people who've been coding for a bit and maybe have not gotten the best advice and are looking for they know a bunch of things but they don't really know the correct way to be doing things and tend to make a mess of stuff. That's where my advice is best. And the article that I wrote has most of it. Like it literally, if you just read that article and like really understand what it says and just try to do that for a few projects, you will get much, much better if you're in that sort of a place. It's the type of thing where like I probably couldn't have taken my own advice back at the time, but if I could have, it would have made a huge difference. Okay, so this is the correct test. So it's pure compile diff, right? Oh wait, am I dumb? Breakout? No. What did I do here? Yeah, 78 mil. teaching beginner. I don't mind working with newer people as long as they have the right mindset for it. I mean, the thing that usually happens is there are a lot of people that have done some programming, maybe even for like many years, and just have not had good advice. Programming is terribly, terribly taught. Like the vast majority uh, of programming instruction, even at the best universities in the world, teaches you to be a terrible programmer. Programming really is not complicated. It's very simple, but it's not easy. Simple does not mean easy. And the vast majority of programming instruction vastly overcomplicates it. In fact, I was guilty of this, right? I wrote Python for 10 years. I wrote a bunch of crappy code. But the thing is, I spent so much time trying to understand all the different ways of doing stuff and like really caring about writing better things that when I eventually sort of stumbled onto the right path, within a month, I was set. It was like a very, very quick change in the way that I approach stuff based on my previous experience. And a lot of people can do the same thing. Like I've seen it happen with several of our contributors. I mean, this is why I like C so much. If you just if you just try to write things in C in the simplest way possible, it just doesn't give you the tools to screw stuff up. It's a very simple language. Old school. No, see, actually, old school C is the simple thing. Like, if you just don't use double pointers almost ever, I mean, your main tools are conditionals and loops, and that's it. We have like 50,000 lines of C in Puffer. That's not like just bloated, right? It's for 30 different environments. Uh, our individual chunks of C code are the same length or sometimes shorter than the equivalent Python and 1000x faster and more readable. Hard disagree? You haven't seen our C code. Here, let me link you this. Here, let me link you, like, this is just a simple demo environment, but you can look at some of our other ones. Obviously, there are contributors of different skill levels, but here, look at this. This is one of the first things I added to Puffer, and you'll see that this is super easy. Just skim this. You don't need any of that, dude. Check this. This is a multi-million step per second RL environment for Snake and C. It's 300 lines of code. Yeah, sure. If you like, you can do that type of stuff, but the default in C, if you just like write the code top to bottom in the simplest way possible. Like, you see how simple this is, right? I can show this to any first year undergrad with one course in systems programming, and they will understand this. You sort of need those when the systems get large. Look at this. So here's a miniature MMO in C. It's a few thousand lines, 2,800 lines. Okay, this is over 1,000,000 steps per second on one CPU core. It compiles to web, it compiles locally. We can train agents on it. It's the hardest available environment in reinforcement learning that is also fast. A good 1,500 or 1,000, 1,500 lines of that are graphics. It has a market. You can buy and sell stuff on an exchange. Has an equipment system, a couple different leveling systems. I can show that code to any first year undergrad. They can read it top to bottom. And I wrote that when I was actually relatively new to C as well. Who did the graphics? So I did the like the programming for the graphics. The assets are from Maniseed. You can just buy a license on a one project license on itch. You don't have to be an exceptional coder. Well, first of all, data science isn't really a job, okay? Like, nobody really describes themselves as a data scientist at the high end. To be good in AI, you don't have to be a good programmer. There are people that are very effective in math. I'd say that there are way more people, though, that are ineffective because they are bad programmers than ineffective because they're bad at math. There were a lot of people who were really good at math at MIT that just made a mess because they were bad programmers. Pretty small when you have dynamic entities in a pool. We have entities in a pool. I mean, depending how big the pool is and how often it gets refreshed, you just literally loop and look for empty slots. I mean, really basic stuff gets you very, very far. Large systems. Yeah, I mean, when you get to large projects, right? Sure, when you get to really large projects, stuff is always going to be complicated. But one of the things that I've always been very good at is I take projects that are medium complexity that you could easily have a company with a couple dozen people on, and I have seen companies of a couple dozen people on similar problems, and then I take them down to a level where it's like very, very simple, few thousand lines of code, individual can read all of it, very simple architecture, still super fast. And that's kind of the zone that you want to be in because that's already enough to build like groundbreaking new stuff out of. Yeah, I really like C. Hmm? Ugh, that's weird. Let's do that. Engineering. But I am a researcher, man. So my background is I'm an MIT PhD. I produce the fastest tools in reinforcement learning. I have some blogs on X that you can read. In addition, I have published papers for my PhD. Now I mostly just do my research in blogs because it's a much faster cycle. We have very effective new methods, right, that we discovered because our program, like our code is so fast, we can just search, we can exhaustively search over the space of methods so much more effectively. You know, there's some new algorithmic stuff as well. We have a brand new architecture in the next version of Puffer, so I do both. But like in my mind, science is a set of methods. It's a tool, right? It's a set of approaches. So is engineering. The goal is to advance the field. Different problems in the field are going to require different approaches. And for the stuff I do, it's like 80% engineering, maybe 10-15% science. Good system design solves a lot of problems. Changing the language for extra complexity. Yeah. I don't mind. I will say, Baba, I don't mind Zig. It looks fine. I just don't really need what it provides for what I do. Like if I want an arena, was it area or arena? Either way, you can just implement one in 10 lines if you want, right? There are a couple nice things that Zig does, but I really don't need them. I'm kind of just chilling in C. Multi-stream doesn't pass questions from X. I really need to switch this to Streamlabs or something. Restream is just bad. General rule of thumb is if I don't reply and you don't see it above my head here, I don't see your message. Oops, that's the wrong one. It's this one, right? QL, slightness, yeah. And that's kind of what I figured. Like, the things that bother me with C, they're just a very small number of things where it's like, why doesn't this code should totally compile, this code shouldn't compile, right? You can fix most of them with a standard set of compile flags as well. Most of the problems that I have. You know, like some casts that give warnings, some casts that don't give warnings. It's like a very small set of stuff though, and mostly the other programming languages, they have a much broader idea of things that are wrong, when in fact there are very few things that I think just are not good. $59 mil. I mean, this is closer. So 59.75. Is this consistent? Probably it was using all 16 threads before. 55. Only dependencies are text handling stuff. Graphics API. So graphics, Raylib is awesome. Like awesome, awesome. Um, text, I will say that text processing in C is a total pain in the ass. That one I will admit. Yeah. I mean, this is probably like all the exports or some garbage, right? Dash share or the DL sim in direction. Okay, we can try that. And then after that, I'm going to just try to minify the vec file so that it just doesn't export so much stuff, because it's just super bloated, I think, at this point. What's this? Okay, this is a fine standalone test. It's a fine stand. I'm just letting it write some throwaway tests. It's literally just a compile diff, I think. Yeah, this is fine. It's just a compile diff. This possibly lets us isolate what it is, and if not, then I think I just have to minify it myself. Can you run the muon test? It doesn't pass for me. Which one? Test slash. Is it muon? Passes for me. Into LLM do too much and be like, fuck. Yeah, absolutely. I do not think these LLMs are smart. I think that they're like, the design is very anti-human. Like it's very much the UI and the way that it's set up is very much designed to like make you hand off too much control to it. It's very bad. Um, I will admit absolutely in this case I overused it. My defense is that I'm tracking down some awful compiler pork at the moment, and I was just trying to have it write a bunch of throwaway tests that like I don't keep, but I made the mistake of letting it touch one of the files that I shouldn't have. I kind of didn't notice. I think I actually fat fingered the like auto accept button at one point. So absolutely, I'm with you. Don't overuse these things. They're really dumb and they make you not think. Good to know on my end. Could be Torch version. Could also be I don't have stuff committed. Man, I wouldn't worry too much. Were you the one who submitted that patch? I think it was that you wanted. There was some difference where you want Nesterov EMA, not Nesterov momentum, I believe, for Muon. Because you don't want to match the Torch Muon. The Torch's version of Muon is wrong. They use the wrong momentum. Might be disturbing you. What are you doing here? I'm new and I'm interested. So I do high performance reinforcement learning dev. I stream all of my research, and we also do a bunch of engineering to make everything very fast. At the moment, I'm working on a multi-processing backend for running a lot of simulations in parallel, and we have it running really fast in the test. And for whatever reason, when I put it in the main build, it's not fast, or there's a performance gap at least. So I'm trying to figure out why. 68 mil. Is that it? I don't, doesn't pass on default. It's probably some library version. Okay, that's good to know. Here. Are you in the container? I've got Torch not 291 here. I think this is a CUDA 12.8 build. Pre-extracted locals. No, it shouldn't be doing this. Container own version got a test on Puffer Tank. Fair enough. I mean, Puffer Tank, like, I'm gonna have to add a bunch of packages and stuff for 4.0, I'm sure. My goal for today is to figure out our NVEC stuff, because that's driving me nuts, and then to really start cleaning some things up. And then we'll see if Jonah comes back later with BF16 or if it takes him another few days. We've had two awesome new contributors that have both just like rocked some low-level optimization on the latest code. Got us from 9.6, I believe, up to or 9.8 up to 11.8. So I think about 1,000,000 steps per second each off of them. What is it doing? Wait, I'm very confused. Why is it doing this? Pre-extracted locals to eliminate pointer chasing in hot loop. There's no way it's that. I mean, I guess. That's worth putting more high quality C. Well, this is not high quality C. This is a god awful mess. I will clean this up. Oh, actually, since you're an experienced C dev, I actually can I run this design by you real quick? Um, because I'm having a this is like nightmare hell of shared library stuff at the moment. So we've got like 20 different environments. Um, we've got like 20 plus different environments, right? They're different simulators. They all have the same API. They need to be multi-threaded. Every experiment is only ever going to use one environment. So the design at the moment that we have is I have this binding file that has the multi-threaded code, and it just like has a couple name macros to define the API for different envs. You compile that entire thing, so the vec plus the env, as a single shared library, and then the training code just dynamically loads that. So you just load the DLL for that, or whatever, the shared object for that, and then you can train. And then the point of doing this is that you can very quickly recompile and build any of your environments without having to have them all included. So if you have bugs or compiler quirks with one env, it doesn't stop you. Also, the torch build is super slow, and this build is instant, so it lets you recompile your env code really quick. The annoyance with this is that I end up with some weirdness with shared libraries at the moment, where it's really difficult to find where some small performance drops are coming from. Is that like a completely stupid way to be doing it with shared libraries? Because I can't think of anything else that would let you like have a fast compile path and not have weird namespace collisions, etc., etc. Okay, this is a reasonable thing. We play with some flags. $68 mil. It's so weird. Other constraints, torch like that. It's mostly like torch is this big, absolutely terribly designed C++ library, right? And our environments are really simple, clean C. And then the multiprocessing code that we have, or multi-threading code, it's like, maybe a couple hundred lines worth of stuff. It's not that complicated. It is very fiddly though, and it needs to be applied the same to all the envs. Well, there are no docs because this is all in development, right? Like this was not how we had it done before. The way that I had it done before, the environments were bound to Python, so everything was just like a standalone that was loaded to Python with the Python C API. But now, since we're not going through Python like that, it needs to be accessible from C++. So that was the best way I could find to have like the C included with C++ without having the super expensive torch recompilation every time. Let me get rid of this bot. I mean, the nice thing about this, look, extensions, if I look like this is the type of binding file that you write. So you write something that looks like this, right? You can see that I have the env macro defined. I've got a couple size macros defined. I've got a couple standard functions here. And then this is used to hook into the environment. And as a result, you can run multiprocessing or multi-threading on all the environments like this. But you need to do shared libs. And I don't know if there's any good way to do it without shared libraries. Oh, okay, so you take this massive, massive hit. I wonder how it scales. Hang on. We might be like looking for nothing here. Yeah, we might just be looking at nothing. Test multi. Oops, expected 2, have 3. Be like this. Really interested in learning. I'm still a beginner, learn fast. You guide me on what you learn. If you're new to RL, you start here. If you're relatively new to programming in ML, you start here. These two guides, they're on my X, which is at Suarez. All free content. Okay, this is 6 mil. So times 8, 48, gets up to 30 mil. It's not terrible scaling. So I guess the thing that I'm concerned about then is let me see what happens. So wait, if I go from 32 to 65, I want to get to the point where I'm no longer, and basically everything is always not cached. And we don't get slowdown from more M's anymore. Basically where we get no caching benefit. Okay, so we're here, right? There's no caching benefit almost. But then for some reason, when you multi-thread it, it still goes down, right? That is so freaking weird. That is so freaking weird. Honestly, with it being this variable, I think what we do is we go clean up, we export as little as possible, we track performance, we keep monitoring this gap, but like this can literally be a small caching difference at this point. Because I think the caching makes more of a difference than anything, so relatively small differences in how this is put together are going to make different, like decent differences in perf. We should get GPU bound anyways, so that's probably what we should focus on. I think I'm at least satisfied that we have some better understanding. I'm gonna use the restroom real quick, maybe grab myself a mug of tea. I'm gonna be a few minutes, and then we're gonna start on the next segment. I'm live all day. I'm only an hour and a half in. This is like minimum 8 hour stream today. No clue, would have to look at it. It's on GitHub. It's kind of on GitHub. Actually, I think that the version on GitHub is reasonably clean. Let me link you this, and I'll be back in a few. So, PufferLib. I think this is relatively good. I haven't committed a mess to this, have I? Backend, C thread step. Yeah, so there are a couple different backends here. Probably we're only going to have like a simple OMP one by the end of this. So this is more complicated than it's going to be. But the idea is this env binding file plus this vec-env header that's in here get compiled as a single shared library with each different of these environment binding files. Like this is an environment binding file. And then you get a shared library for loading that env. I'll link you it, and I'll be right back. I'll be right back. Let me grab a mug of tea and we'll keep going. Okay. I am back. Let's get cranking. So, first thing, we are exporting way too much crap. Hey, Liberty. We've been checking on vectorization performance, and we're going to start just massively cleaning up Puffer today. I don't like this macro. I can actually get Claude to clean things up here but I want more control, so I think we're going to do it this way. Export. Opaque and pointer. Oh. Okay. Let's run one. Let me just check one last thing. Just want to make sure that we're doing what I think we're doing. Lovely. I gotta get Docker to stop dropping GPUs. That's super annoying. Huh? Oh. That's weird. That's very weird. Driver crashed. I don't think I have anything super crucial on here. It'll come back up in a second, though. It should at least. It'll be very unfortunate if it doesn't. I do have somebody who can turn the machine back on there. If it doesn't, that's a very screwy error. I have not had to reboot that machine in a long time. I had that on both of my machines today, which leads me to suspect there was like some weird system thing. Yeah, this is not happening. That's such a weird thing. I would think Elon would understand that, given he plays a ton of games. That's just like not how it works, dude. Oh, come on, come back on, machine. I'll give it a minute. That's gonna suck if that does not come back up, though. So basically, the plan is at the moment, we make sure that the new end thing is faster. I'm almost sure it is. We strip out all the old redundant tests because they're also exporting a bunch of symbols that's doing weird things as well. We profile GPU transfer bandwidth. We have the main PufferLib C++ and modules and stuff to clean up. We start trying to get all of our performance tests aggregated into one nice spot so we can get all of our performance tests in just like one nice suite. Is this machine really not going to come back up? Like, what is going on? Why did I have both of my machines do this today? Oh, no, it did. It came back up. Good. Yay! I don't have to get distracted by random bullshit. Good. My 6 mil. So on GPU, on CPU we're at 62 mil. $72 mil. $28 mil. Ooh. Huh. When I tested this before, it was a huge difference. That's a little irritating. I don't think drive works with this either. No, it doesn't. So I guess I have to keep both back ends. Man, this Vec stuff is so jank. So incredibly jank. We still have too much stuff. So like they just clean stuff up stuff in general is still the right thing. It's just that there's also some annoying testing. Yeah, delete all the barrier crap. Back OMP step. It's fine. It's fine. Init. Reset. Okay. Export C step. Yeah, we don't want these. We'll do that. I actually like that as an interface much more. I don't think that this like separate window thing is good. It should definitely live in your editor. The mistake was that that doesn't mean you need an IDE. It can live in Vim just fine. So delete a whole bunch of the tests that we don't need. Don't need this. Don't need this. Yep. A whole bunch of crap. So yeah, this will be cleaned up. I mean, this is all just like deleting Claude's crap in the first place. So we do use this to write a bunch of throwaway tests. Now we delete the throwaway tests, and we end up with the newly optimized version of the code that I actually wrote, which is good. Yep, get rid of the p-threading crap. We're just going to use OMP for this. And then it should end up deleting some tests from test undefined. 770 lines. Still way too long. But we have 2 backends still. Yep, so we don't want any of these inner loop functions exposed. I'm pretty sure that means they don't get inlined. There's some optimizations the compiler can't make if you expose everything like this. Now I'm confused because I thought this was way faster than the previous impl. It also doesn't work with drive, so we're gonna have to figure that out. We'll consider this simultaneously part of the cleanup for env binding as well as some of the testing. I do not want to be working on just env binds all day though. I really want to have like at least a good 3-4 hours to just clean up Puffer as a whole. Yep, so a bunch of these tests go away. The direct test goes away. Multi goes away. Because we're no longer exposing the functions we need for this, which is good. This was like a mega test, which was bad. A lot of the compile stuff we were doing would actually mess this up. And then hopefully we can run clean version of test with same result after this, or slightly better. Alright, so now, oops, go back, breakout, and we do env speed, breakout, direct. Can we do this? Oh, I guess we can. It's kind of weird. Step direct. Oh no, this is fine. Because it just calls, yeah, this is totally fine. Because it's still a vec function. Oh, minimal. $55. That's slow. CPU. 60 mil. Old implementation. 50 mil. That's something. Now I think we have the device transfers wrong here. So the idea is the actions are going to be put on GPU, but we don't know what stream. Yeah, there's a synchronize. Style nits. Puffer and each env ports that one symbol. Wait, I define a single puffer env API, and each env exports that one symbol and have a version check. Puffer. How do you do that? Wait, exports that what one symbol? So things that I need from the environment, right? You need to have there's a step function, there's a reset function, there's like a close function, there's a render function. So there are a few functions. The binding files, like those, the shared function and the init function, it's for passing args to the DLL. The shared one is because sometimes you need to pass shared info to all the copies. If you have a thing that you think is cleaner, though, I'd be very, very happy to take a look at it because, I mean, in my mind, it's very important that this thing end up being nice and clean. And it's not even that much work if I have to refactor 20 M's worth to it because it's basically automatic now. Yeah, so this is what we want. We pass CUDA stream T, and synchronize stream. No device synchronizes. Be very good. Or make sure it doesn't mess up. Yes. Oh, did it mess up? Hang on. No, that's fine. Hot reloading. The host owns the state block. Engine runs and can just load the game. Wait. For hot reloading, the host owns the state block. So So the engine runs and can just load the game DLL. I think the application is a bit different here. Let me think. Well, we're not really trying to do hot reloading in that way. I think we do own the state block, right? Because like for the vectorized init, we create a big array of ends. And I think that's done on host. Assuming you mean host process, not host like the CPU. This is good. I want to avoid the torch. Yeah, I don't want to have to like do the big heavy compilation for everything. I mean, I wouldn't have this problem otherwise. So I don't want the torch compilation for this, but also I don't want to have to like, I guess we could technically just rely on caching for all the other ends, but I don't want to have to include all the environments every time you build the train loop, right? Every time you build training, you just should be able to build the one end. Load, unload. Yeah, we're not looking to load, unload while running. I mean, our game builds, in some sense, like the standalone build for the games it's instantaneous anyways. I guess technically we could do hot reload for like the dev loop a little bit, might be okay. Hmm. $110% less. I think it's messing this up. Hang on. Depends which test it did null on. Null is default stream. That's fine then. Oops. Hmm. Okay, they're the same speed now at least. The OMP one doesn't segfault, which is nice. Cool. So we need to queue up action transfer, don't we? Because the idea is we get obs. What if we don't synchronize the stream? Wait, I think we don't have to, right? There's one spot we definitely have. We have to synchronize a couple things, but I don't think we need to synchronize everywhere. It's actually, the OMP one is so much easier to think about. So you run your net, right? Well, why did it do this? Huh? Ooh. Yeah, we want these streams to be... I see what's wrong. Okay. This is the only spot we need syncs. So actually, in Vex step, it's Vex send, Vex receive. Okay, yeah, this is a mess. Now, where's our... We have the OMP function, don't we? Yeah, Vex OMP step here. Did not update the, Yeah, it didn't update the OMP one. I also think we can just make this be the same stream. That would be really cool, right? If we just have Torch be on the same stream. I think that's what it's going to end up being. Yeah, that'll be so much better, right? So imagine then we have the network. You can do that, right? You just call... Yeah, you can totally do that. You have one DL sim. Buffer and... Oh. I didn't know you could do that. Cool. Yeah, cool. I guess also, Papa, can you tell me so everything that you export, right? The compiler can't inline. Does it make sense to have wrapper functions for stuff? Like, let's say if I want to have the single end step function, right? So that gets called in a tight loop, so you want that to be inlined. Um, but like, let's say you also want to be able to call it directly. Should I essentially wrap it and then expose the wrapped version so that the original still gets inlined? Because there's definitely compiler shenanigans going on here. Like, I'm getting perf degradations behind the shared barrier. Version size to API struct and you validate that it matches, which is standard to not fuck something up. Okay, that's actually really cool. I didn't know that. That's nice. That is nice. Yeah, we are definitely very loose around like that type of stuff here for sure. Because I just maintain so much of the stuff. I kind of just fix a lot of things manually. That's definitely a good thing to do though. Welcome back, SPY. This guy will grow a reasonable sense of humor in a couple of years. I am curious, do you like learn stuff while you're here? Because presumably you come to like this specific tech stream for some reason. I do that too, since point of call from loaded SO can never be inlined. Yeah. Okay. Well, that's easy to do though, at the very least, and that's like a one-time. Start freelancing in backend. Good luck. For company and to ask annoying questions. I don't learn anything, just play the stream in the background. Well, there is some cool dev going on here. I mean, this is actually the fastest thing out there in RL by quite a wide margin. Not to mention, we do have better algorithms and like some pretty unique tech as well in here. Not just faster. Okay, so here's what I'm thinking. Can we run the policy. We have multiple. Pure jacks, it's slower, we're faster. Our code is simpler and faster and scales better. Jax is trolling. People like Jax because like it makes it very easy to get kind of okay perf, but it's at the price of not being able to really write interesting envs, having to write absolutely insane code that is essentially a DSL of Python. It obscures a lot of stuff. It makes really serious performance optimization almost impossible. And it adds a bunch of compile overhead. It's just a bad call everywhere. Okay, this is cool. How does NVIDIA GPU work? Can GPU handle complex logic and ends? No. GPUs are terrible at branching logic. Which is why you have all these JAX demos of like, oh, it's pretty fast for simple M's if you run 32K M's and have relatively simple logic. And then nobody's done anything like the complexity of puffer M's that's also fast. The best example out there is something like CraftX, which gets 100K steps per second for just the env, and then you've spent your entire GPU time on the env. You don't have any left over for training, so you'll go down to 50K for training. And the logic for that env is a total mess. Like, don't get me wrong, the guy that wrote it is brilliant, but it would just be dramatically simpler and faster to do it in C. GPU stepping. It's not faster, because you're spending your GPU time on a task that it's not designed for, and not on training as well. So like if you're simulating CraftX at 100K on GPU, yeah, now you don't have to move it from the CPU to the GPU, so you save that, but like your env is slow. You could just have it run at millions of steps per second on the CPU, buffer the transfers, which is what we're doing right here, not have very much overhead on the transfers at all for obs that size, and be running at training faster as well. Hot loops are not cross-boundary. Wait, make two compile options. You can do static or vtable. Loops are not cross-boundary. You shouldn't lose much. Static or the vtable dynamic approach. I see. Well, I mean, I can see I'm losing a bit because I have, I have the standalone vec test, and then I have the, I just like put it behind a shared library. But I don't know if it's just because I'm exporting too much stuff, or if I have weird flags. Okay, so this is totally fine. You can probably get 1 mil plus if you join XAI. Yeah, or any of the other labs. I don't want it. I'm way happier doing this. I do think that I'm going to be, I mean, that this stuff is going to make plenty of money as well. It's not the primary objective, but it's a secondary one for sure. I mean, we do have active contracts with a few different companies. We have a couple big ones that we're working on signing Q1 as well. And then we also get to do all this, not behind closed doors. In my mind, this is an area of science I've invested a decade of my life into, and I don't want to see this get moved to behind closed doors in the big labs. Like, one of the reasons that I'm making everything so fast is because once you can do this on your laptop, and the code is super simple, and relatively new people can at least get a hang of the basics of it quite quickly, this tech will never be lost, right? And it's incredibly powerful. It's completely different from what's going on in the rest of AI. And I think it's going to be just as impactful eventually. I think people will see that. Working on stable, yeah, Jess, we are working on stable alpha, but there are also some weird things going on with the end findings. You to do an LMRL contract a lot because it's a total distraction. I also just don't know why you would, right? Like, I don't know. I've had a few different companies try to, including X, um, like want to hire me just like as a generally smart person to go work on their stuff. But like, that's not really what I'm interested in doing, right? The stuff that I have here for RL is really well suited to a specific type of problem, and there's not really a point in trying to force it on a different problem area. Like, yeah, I could go shift gears and focus on that, but I'm not really interested in doing that, you know? Okay, so yeah, now we make our own streams, right? I think this is good. Now we no longer need to, okay. So essentially what this is now doing is we're replaying the policy on the same stream as well. So as a result, I think we have no more synchronizations, except for the one for, obviously we have to sync before we step the environment, because we have to make sure that we're done computing things on the GPU and the data's ready. Let me go see where this is. Okay, so right here. Yeah, and there's no more sync. These agents. Is that more really? It could be, but not really. It's just like, that's not really... I honestly don't find those problems particularly exciting or important. Yeah, it's neat, Jess. Like, I want this stuff to eventually go to improving scientific simulation. All operations get stream from external. Stream guard. That's kind of weird. I think that all this is wrapping this as a torch stream. Oh, wait, actually, why did you freaking do this? Hey, put my profile macros back in there. Real gear shift. 5 or 6. Critic stream, that looks more likely. Okay. And put my profile comments back. It's stuck, doesn't know whether it's C10 or AT. I actually don't know either, though. I mean, it's very easy to check. All right, cool. Type redefinition. Probably forgot to update backend. Yeah, the backend callback, no biggie. I don't know if you can include this here. Should be compatible, let's verify. Yeah, so we passed void star, so we don't have to include that in the backend. What 6 looks like? No idea what 6 looks like, Jess. This type of standard. So I don't think that you're going to want one physics standard because fundamentally there are different scales at which you want to simulate things. And the main sin being committed by numerical sim people is always trying to make everything as accurate as possible without regard to the level of accuracy needed to actually solve the problem at hand, and therefore making things very slow. So that's actually the main thing that we don't want to do. Now, there may end up being commonalities where we find groups of problems that can share the same backend. I would not be surprised. But I don't think that's going to be like, that's not going to be the imperative, is like to find that, right? D6 mil. 33 mil. It's faster. Now we do need to have we should simulate a mem copy, right? Should we wait, hang on, let me think. Should we be simulating a mem copy? Or a mem set? We should, right? I mean, that's a very fast op, though. I think this is okay. Yeah, this is fine. So this gets a 33. So now what we can do is we can do native one. 50 mil. 25 mil. Cool. Our new vec is in fact faster. Let me see if drive still works on the old one. Ooh. Self-play port to 4.0. I don't think it should be hard. I mean, I have to see what you've done, right? Like most of the janky stuff that I'm doing, frankly, it's it's at a lower level than your code exists at. Like just the if you just write the Torch C++ API, their code's a mess, but it honestly looks almost the same as the Python. It's not that bad. It's when you're doing like manual CUDA graphing and custom kernels and modules, like that's when stuff gets fancy and weird. So just porting some chunks of the Python to the Torch C++ API will not be that bad. Also, there is a Python compatible version. Like Puffer4 is not going to be C++ only. We will have Python exports for stuff, but we're going to do it at various levels, right? So like, for instance, you'll be able to call our graphed forward pass as one C++ call, or you can do it more granular. We're going to basically have it so that all of our optimized chunks get exported. You can also just write normal Torch and it'll work, right? It's just that our stuff is so nicely optimized. Like, when everything is so fast, almost anything that you do that is not optimized, like you'll see a good dip in SPS. You know, you'll add like one random Torch op and you'll lose like 10% each. This is what it takes to make stuff fast. What? Ellipse. Vec M's indexed by environment. That is probably it. Good. What? Wait, how does this change? Ah, yes, I see. This is correct. Just a minor indexing bug. Talk to Spencer about it. Only pseudo-complex thing is we currently have an opponent pull on GPU. Some standby on CPU too. To avoid the delay of loading models. That's fine. Why do you even have to offload them, man? The models are tiny, no? It's a few megabytes per model. How many models do you have? Oh wait, that's 1.46 mil on GPU, isn't it? Dota does not cap the pool. Okay, fair. Do we segfault? Ooh. Look at that, it's a bit faster. That's nice. We run CPU, a 1.7 mil throughput. Should help. So 2.19 on CPU vec. And then if I do normal, okay, I think I'm happy enough to just like keep this. Is there anything else I would change with this? It's just a bunch of synchronization overhead, right? Let's see. Oh. Still does not have the full. Chess is going to be so good once that project is like fully mature. Because we need more of these really hard environments that you have log linear perf on, right? Because like we want a bunch of environments that are really stable, that have log linear perf with compute under optimized settings, so that when we make algorithmic changes and like we can essentially just test, does this change the learning curve of these really hard environments? That's going to be the main thing. In envbinding.h, there's redundant device sync. Yes, so that's what I'm messing with right now. Let me show you why that's there. So in the version I'm working on, if we go, where is it, vec receive? They already sync before, returning after. Wait, they already call sync before returning and after host to device. So this is, it's changed to a stream synchronize. So the issue that I had, the reason that there were synchronizes here before, we didn't know what stream torch was on, right? So torch would give you back actions, but you wouldn't know what stream. So you had to sync the entire device in order to make sure that you had the actions computed. before you could then move them on a different stream to the CPU. Now what we're doing is we're just setting the stream of the model itself, and we should be able to remove pretty much all these synchronizes. Yeah. Actually, thank you for drawing my attention to this, because I think actually this one as well, probably. Since now, if the models are on the same stream, right, we actually don't need to explicitly do as many synchronizes, because it just won't queue up ops out of order. Why would there current algorithm that log linear? What types of patterns are you hoping to get? Just ELO curves are typically log linear with compute. Right? Like the Dota ELO curve, for instance, is log linear with compute. Most of these projects have ELO curve log linear with compute. The thing is, ELO itself, like, skill is exponential in some sense. So it's not like log linear is not bad in that case. But we might end up being able to do better like with different algorithms, either by like a very large constant factor or some problem, or by some factor that scales with some other aspect of the problem. I think ELO is probably still going to be log linear in some sense, but like there might be other aspects of the problem that you can remove that scaling from. Come on, come on, come on. Give me the signature update. I'm going to remove these syncs and we'll continue from there. Okay, so this is good. So we can do this. Oops. That'll get we're there when we get there. Yes, we do. For 5 we do, not for 6 yet. I have one version out, Jess. There are two different things around exploration that I think are like not bullshit and actually likely to work. Actually, I'm gonna be playing I've got like a game session with a couple RL researchers I know that do exploration stuff. We might even stream it for the hell of it this weekend. We'll see. After my Saturday stream. Segfolte. Yeah, breakup segfolds. Lovely. Like you play games. I don't stream them normally, but I mean it's 4 RL researchers hanging out playing a game and probably chatting about a couple research things, so we might. I mean they like one of them suggested it, so I'm considering it. Segfaulting in log environments. Which what do I play? Me personally, I've just been playing a bunch of RuneScape in the evenings. I I downloaded that game after 3 years off, but you know, Puffer's in a good spot, and I figure I get to enjoy my game a little bit again. But then we're probably gonna be playing Barony. It's like this roguelike dungeon crawler game. that's very similar to NetHack, and both of them do research on NetHack. Log environment simple. Okay. What the heck did I screw up with this? Does it need to sync before we log, maybe? It might need to synchronize before we log. Yeah. Let me try this real quick. I wouldn't be surprised. It's just this. No. Should I add automatic domain randomization, or should I keep the same difficulty of training the entire run? Ooh. You can try adding it. It's a little bit tricky though. Automatic, it's complexity, so you can make it work, but it's not an out of the box thing. I guess what it depends on is it depends on the magnitude of the gap in complexity from the start to the end of training. Like if I wanted to go from size 5 to size 1000 mazes, for instance, I'd probably need it in our normal training runs. So you get a little bit of it for free with the way that our prioritized sampling works. Like it just automatically prioritizes high advantage segments. So once it learns the easy stuff, it'll kind of just start dropping it for you from the training batches, and it will focus on optimizing the harder ones a little bit. But if the magnitude of that effect is too big, then our implementation will break down and you would need something more dedicated. For the stuff you're doing, I'd be pretty surprised if it's required. So steps. But you might just be sampling at too high frequency, frankly. That's like a common gotcha. Like training at very high time frequency just creates these really annoying extended credit assignment horizons. It's actually, most of the time, it's not the episode length, it's the number of steps between rewards, if that makes sense. So, like, having 100,000 step episodes is totally fine, or never resetting is fine if you're getting rewards every few dozen steps, or every 100 steps, even sometimes, right? But now, if the environment is changing a lot such that it looks very different at the end of the episode versus the start, that's different. Mostly dense. Then episode length itself is not a problem per se. Presumably, you have dense rewards in a way that's reasonable, like the delta-based rewards instead of the constant rewards. That's a common gotcha. It's already set up as deltas in the drone env from Puffer if you use that as a starting point. What else? Yeah, that should mostly be fine. The other thing is really long episodes. If you're getting heterogeneous data, you do want to have all your episodes offset. So if they're the exact same amount of time and they're really long, you're going to get a batch of data from the start, then a batch of data from the middle, a batch of data from the end. That's bad. So you want to at least randomize the offsets of all the different ends. Those are a couple of common gotchas. Yeah, that's funny. Stupid. Try randomizing offsets. Yeah, it's just a common gotcha. Environment changing, just to makes the start more difficult after it's stable, it's going to be solved. Could be. I mean, what we do is our sampling, it grabs batches of data with a high absolute advantage. So as long as you have a decent amount of signal in each batch, it'll go grab the high signal batches. So like a lot of the instability is kind of handled for you in that sense. It's one of our key algorithmic improvements that we made with Puffer 3. It's fine. Randomize the offset. So for really long games, if there's a timeout, for instance, like let's say every game times out at 300 steps, so like it's always 300 steps, then you want to start off you want to start the ends off at random times just for the first iteration, so that they get they get all offset from each other, so that you get data from the start, middle, and end in every single epoch. Kind of insane how stable Puffer is. It's gonna get better too. We have 11.8 million step per second training in dev now, and I think we can get it even a little bit faster. That's still in FP32. We haven't even done bfloat yet. We have like a brand new architecture for Puffer 4. We've got some sweep improvements. We've got new environment backend vectorization. We're going to do Constellation. I still have to finish, but it's like large scale experiment visualization stuff, which is nice. But the main thing is just everything is so low overhead now that your typical breakout experiment that we use as a test case is going to be about 3 to 4x faster than it was in Puffer 3. But then there are going to be several configurations of training that you might want to run that would just be 20x plus faster than Puffer 3. Because we've cut down overhead, right? So anything that was like really strongly dependent on the torch overhead is now going to be way faster. Now bigger nets, like bigger networks are going to benefit less, which is why we also want to get bfloat 16 in, because at least then there will be one major improvement for these M's. But I think like pretty much everything will at least see some reasonable benefit. Had this problem early on in chess. It solved itself, but I wish I knew back then. Yeah, it's a common gotcha. RL Pros messed this thing up too. One of my buddies, Stone, wrote a paper about this, like, hey, all you roboticists are trolling. You're just all screwing this thing up. It was pretty funny. Does this work now? Think about dev loops. Yeah. Dev loop's important. Okay, this is only 10.5, so I don't know where our perf went. It should be 11. Oh, our vec backend, obviously, right? Yeah. So vec backend should do it. So unless I broke this. Deploying 10 models an hour. Yeah. Holy shit. Okay, it's not stable. It's not stable. Never mind. We're probably just skipping a synchronization. If this is real and like we just have a bug, 14 mil would be pretty cool. I don't think so though. I don't think this is real. That would be pretty cool. Let me go grab a new mug of tea and then we'll figure out if we actually get 14 mil or not. I don't think there was that much overhead in the end in the first place, but maybe, I don't know, maybe we have different torch streams now, who knows? I'll be right back. Okay. Sweep. What's this? Sometimes even FPS is highest on a certain amount of epochs. Yeah, you sweep. That's it. We missing? So you need this synchronize. No sync here. We're gonna try adding a couple synchronizes. Just because like something's screwy. Oops. Yeah, it's not doing it. Should start. We can try one buffer real quick. It's like, why do we have 4 buffers? Okay, this is not it. It's probably something dumb with the streams, wouldn't you think? More duplicate exports, okay, sure. I mean, adding syncs doesn't help. Everything has unique stream. Maybe the follow-up call is not being on the same stream. No, but because then the thing is that would have been solved by the synchronize that I put in. It should have been solved on a different stream than what we're using. They are being. It said that was fine. Maybe not, though. Don't start separate streams before tracing. Current stream. No, it makes a capture stream specifically. All custom kernels need to use the default torch stream. Wait, all custom kernels need to use the default torch stream. Oh, hang on. Torch stream functions, not the C10 ones. It's probably that. Get current CUDA stream. That's actually fine if it gets set. GPU ops, which might be uninitialized. That's from vec reset though. That gets synchronized. I think that's fine. So let's just go false. False. Is this train? Yeah, this trains. Okay, so it is actually something with graphs or whatever. Let's do 2 buffers. It's pretty easy to isolate, right? Oh, this works. What about custom kernels? Custom kernels breaks. Oops. What about CUDA graphs? No, see, this doesn't work either. It's stable, right? That's what we want out of a learning curve. Look at that. Yeah, I think this is probably it. We'll go check my context guide, because this is stable. Shared RNG offset tensor. I don't think that's it. Because it's also screwed up with just CUDA graphs, right? So yeah, that doesn't make sense. Stream guard. It's, yeah, so this is not what we want. Make sure you're using torch stream function, not C10 ones.
Testing.
Jesus. What the? I swear, it's always something. I have the alarm. Literally, it's right above my desk there. Can't hear anything out of my right ear. It's not going to get traced. Yeah, this is what we want. Now we match this function at least. That could do it on its own. Let's go double check. Of course, it could be two different things. Probably is two different things, right? No, actually, it could just both be that. Because if it's not setting the stream correctly, that would totally do it. Unfortunately, I don't think it's this. Yeah, it's not a quick enough learning curve. It's interesting, it's learning some stuff. But, not quite there. Just custom kernels work. Health to fitness. I have several articles, Jess, on the X. Does it still work with, does it still work in this mode? Hey, Peru. Your VEC has worked very well. I'm integrating one additional thing with it now, and I'm trying to get it to work, which is, we're trying to have the torch model be on the same stream as the end buffer so that we don't need to sync. Okay, yeah, this still works. That was one of the things you did, right? It's like you made it so that the net call and the end buffers and everything, like if you have two buffers, it's two different streams, right? Each buffer had a stream, and the network as well, right? Was on that same stream. Yes, okay. Try something real quick. We're getting like crazy 14, 15 mils SPS, but it's broken at the moment, and I don't actually know whether that would seem high to me. I don't think we can actually get that high, so I think this is just bugged. I have confirmed that the implementation works, though. The 11.8 number is real. Like, that number at least is real. Let me just do the device synchronize real quick, before and after. Just see if this does it. Yeah, so that was a very big contribution. I want to see actually how big it is with the streams. That's the next thing I'm interested to figure out here. OpenMP just had too much magic. So we wrote the smallest version of it. I tried doing that and I couldn't get it to match perf with OpenMP. I didn't like this. I didn't like the C++ here. I wanted to keep the threading back in just C. That was the main thing with this. I have been reading this though for reference. Like I've been reading this and trying to take the techniques. Yeah, I really want to minimize the C++ surface. I hate the torches in C++. Their C++ is absolutely terrible. Like minimal, really simple C as much as possible is what we're trying to get. It's really not even that bad. I actually end up doing pretty much the same thing as you do here. Like I just pass one void pointer for the network. Here, let me see if this did anything. Oh, wait, this trains. Like an intro guide, or do you already? You really don't need an intro guide from me, Jess. You just go grab Strongless or go grab a pair of running shoes. It's that simple. Buffering with train LSTM, match Python. So the LSTM arch doesn't parallelize over time at train. Yo, you missed my question. Oh, I should be manually resetting the LSTM state at the end of each game during rollouts for chess. In PufferLib, manually resetting. This is one of the things we kind of punted on, Spencer. We just don't reset at the moment, except between. At the moment, we are resetting between epochs, which is probably the wrong thing to be doing. And probably just by messing around with when state is reset, we can probably get a lot of perf on the few ends. That would maybe make sense. I'll play with that. Yeah, this is like one of the things we definitely need to mess with. I messed with it for a client and it does make a difference at one point, but like it also can mess stuff up, right? Because it can let you meta learn across rollouts, which I remember with the drive end, right? It would meta learn like it would get to the goal once and then it would just go straight there because it would know where it is every time. That was one of the big bugs we had. Resetting on crash. Yeah, it can. It could. That's reasonable. I would think that resetting the state is like less important than keeping the state across boundaries, but I don't know. We can try this. Yeah, we can try this. LSTM does not favor will min grew. I think so, Peru. We need to run all the experiments. I mean, if you get it really fast, then sure, but like, you can't parallelize the training is the issue. So it forces you to have really big batches, really big mini batches, or really short horizons because you can't parallelize the time dim at all. So it's like it's not always bad, but it restricts what you can do. Can you paralyze? You can't paralyze GRU, but you can paralyze min GRU. It's a different architecture. There's also a min LSTM. It lets you paralyze not the full thing, but the gate is still not parallel, but the matmul is parallel. So you can batch all the matmuls. Anthropic tax. I gotta go get I'm gonna stop giving these fuckers money. I don't know, is Gemini any good? It's kind of sad that I think the least bad of them is Google at the moment in terms of people I am happy giving money to. Credit bill's probably going to be lower once I finish the refactor. Hey user. Struct. Google's world model? No. Is it not all over timeline? Yep. I think this is bad, right? Yeah, no, this is off. Okay, that wasn't it. Okay. It just needs to go, wait. It's here, right? Oh wait, hang on, am I dumb? It's just not doing the rollout on this. Yeah, okay, we're dumb. Did that just break it? Hang on, did that break it or am I? No, it has to go here, right? Yeah, that broke it. So undo that shit. That was bad. Used on any CUDA stream except the null stream. Except the null stream. It's probably that. Yeah, there we go. Do I have it here or here is my question. Oh, that works? Wait, does that actually... That works, really? Interesting. Okay, so this one, like, kinda works. And then this one really works. Probably just being on the wrong stream. Weird. Sick. CUDA stream and then previous stream. Policy forward. Set current CUDA stream. You know what? Wait. Previous stream. Stream to stream pointer. It's gotta be something with the stream set. Open source model times 90% of what Claude does, 7x cheaper. Eh. Wait, what do you mean the same guys that did Muon? Keller? Isn't it OpenAI? Hey Weston, how's it going, man? We are fighting some coup de graphs. And we have the clues in front of us, right? Trying to catch up on the stuff. Back down in SD, leave for in June 5 days. That's cool. I'm still in Florida, man. Otherwise, I would have been happy to chat, like, to be there in person. But I ended up only being in California for like a couple days on the way to a vacation and a couple days on the way back. I was barely there at all. First to use it. Those speedrun guys were the first to do stuff, right? There's Keller with a speedrun. Buffer got there pretty quick as well on RL. I think we were definitely the first for this type of work, the first to adopt. It took a full hyper like resweep was the funny thing. Why is it like this, right? Why is it like this? Okay, net callback wrapper, right? It doesn't even, does it work with one buffer? Let's take that out as a possibility, right? Move back to Kelly, depending, should be there most of the time. Tennessee and Kentucky. Yeah, best of luck with all that stuff, man. That's no fun. One clip with QK clip. Wait, QK clip. Does that do something for us? That doesn't do anything for us, right? It's like for attention specifically. Okay. Open weights. I mean, I might play around with switching it at some point, just like set up open, what is it, open something or other? Open code. Faster would be nice. I mean, this is interesting, right? That actually makes sense. Maybe you just explicitly call the CUDA function instead of the torch function. I'm so sick of torch, honestly. NVIDIA just doesn't have a neural net library, right? They don't even have one that's like good but not popular. Underscore. Code clippy. I mean, really, this like these things are not that big of a deal at the moment. Okay, fine. Go find accessor. funny. Raw CUDA graph exec. Graph exec. I don't have opt conda, idiot. It just gets lost on dumb stuff all the time. Mega hallucinates. Why you can send me to do the unimportant stuff? Yeah, but like you're doing chess stuff, and chess is way more important than that. Like chess is actually a really awesome end. Wait, wrote out graphs. You don't need this, do you? AT CUDA. Okay, so this is a torch CUDA graph, isn't it? We played in any stream. So graph exec. Super annoying. Does it have raw CUDA graph exec in here? Okay. This is fun. We can try this. Copy calls do need to be on the right stream, which is why we have it set. What the heck? I'm so confused. Confused by freaking Torch being crap is what it is. Stupid library. I swear. It's just so bad. We're already setting the stream, dude. No, this is fine. Incredibly obnoxious. Is it stream in this context? It's a CUDA thing, man. So you have multiple streams to the GPU, and ops can happen on different streams. So when you synchronize, you can either synchronize the entire GPU, or you can synchronize a specific stream. So Torch doesn't expect you to screw with this. But if you're doing buffered rollouts like we are, and you put them on different streams entirely, you can avoid a bunch of redundant synchronization and save time. But Torch doesn't make that easy because they expect you to be an idiot and only touch their high-level API and have everything be slow. Choose CS stream, sir. What do you mean what made me choose CS stream? I'm just streaming my work, man. This is my normal work. Okay. I don't think this is enough. Jeez, are they gonna do this crap again with the... Hang on, let me mute this. Hopefully not. I'm gonna be pissed if they are. Does this work scale to a large scale training, or is it mostly designed large scale? Well, the thing is, like, you can literally do with Puffer on one GPU what you used to need 1,000 for. So, yeah, we literally train on more data than OpenAI does on one GPU. It's a very different type of scale. Like, this work is not being held back by not scaling to a bunch of hardware, though we can run it on multiple GPUs. It's scaled back by everybody being absolutely terrible at engineering. It's pretty much that simple. What made you tilt towards CS? I mean, machine learning was really just taking off when I was considering what to do. It was always going to be some sort of science or research, and lab science felt very restrictive in some sense. You know, you can do a heck of a lot. You don't need a bunch of equipment. You can do a heck of a lot. Work can move very fast if you're good. Just a lot of things AI has going for it. It wasn't just CS, it was already AI when I was doing this. It was already quite specific. Okay. So this still doesn't train, right? No, this doesn't train. It's not fast enough, we'll see. Yeah, it trains some, but there's some sync mess up. Some synchronization mess up. Does Peru have this? Working with Torch? Oh no, he doesn't, because he doesn't have graphs. Yeah, he probably doesn't have graphs. Okay, if he didn't solve this, I have to solve this. Damn it. Net callback reads from GPU obs. Just CUDA stream synchronize. Okay, we can try this. Okay, let's see if it's the last one then. We can get rid of this device synchronize. No, right? Oh, this is still wrong. So let's try CUDA stream synchronize. I'm curious. See, this is not good enough, right? No. Stupid CUDA graphs, man. This is literally just Torch being crap. So obnoxious. I did have trouble syncing streams regardless of graphs or not. Okay. What did you do? What do you have here? Stream.synchronize. Get CUDA stream. I'm still confused, man. That's C++, dummy. Wait for streams to synchronize before yielding to train. Yeah, it's not enough before yielding to train. It's every iter. Okay, it is the default stream though. This confirms it. Stupid thing. Somehow something's getting launched on default stream. Here's the restroom. One sec. it works with if it works with default stream. I'm wondering if you need Torch Guard to know which stream. CUDA level API may not have. CUDA stream guard. This whole Torch is a mess. It is. It's a total mess, and it's because it's Torch's fault as well because they have wrappers for everything, and you don't know what which things are compatible or not. No, this is not. We're not taking this per fit. So. What's this, the guard thing? Stream guard. CUDA stream guard. They would end up using default. CUDA stream guard will torch to use the stream uniformly. I tried using the raw API. I think that their wrappers do some stuff they rely on. This is why it's such a mess. I think that you're right that eventually the goal is to just use the raw graphs. Man, Torch is just a pain in the ass. I'm pretty sure you don't want to have these guards, but we can try this. Fine, we'll try this. I think we still have the sinks in here, don't we? Yeah, we still have the sinks in here, so don't get excited yet. If I can remove the sinks, then we have something. It's not the same. Dude, how is this thing freaking happening? It's like... so dumb. Is this better? No, right? It's not. Still on the frickin' default stream somehow. I have no idea how. Replay. Replay goes on the current stream as well. It's weird. Torch managed streams. We did this before. Try this. We can try this. Capture perf trace to see which streams get scheduled. I could probably set that. I don't have all that set up at the moment. Torch is just like so freaking bad, man. I honestly think you could replace Torch and like I think you could write a 2,000 line library that would be faster and save you more time than Torch does. I've spent hundreds of hours of my life dealing with this piece of crap in the last few months. It's just awful code. Do it. See, the problem is if you don't have torch bindings, nobody uses your code because everybody wants freaking torch. Library is just awful. I think what's going to happen is we're just going to slowly replace everything that is in torch. And then it'll just be, yeah, it's bound to torch, but it's actually all just puffer code. I don't get it, man. Look at this. It's still... If you don't sync the default stream, it still breaks. I don't understand how. Like, literally how. Does this apply to copy operations? Async has to use current stream, right? Okay, this actually breaks now again. That's bad. There's something going on here. Absolutely infuriating. Where's the source thing? Dude, this fucking garbage code base, I swear. Mm. Make sure it's using non-blocking. Let's try something. Not what I wanted to be spending my day doing. More bullshit torch things. Shitty meta engineers. What? Did they break the network? No. Okay, good. So annoyed. Well, that's bizarre. Now it doesn't work without CUDA graphs. Lovely. Oops. And it does work with CUDA graphs. Doesn't work with CUDA graphs. Man. This is bullshit. Complete, utter bullshit. Like, I hate this. Wrapper is using some other streams. I think so. I don't know. Now somehow nothing works. Yeah, now all of a sudden nothing works. I don't even know what the heck possibly changed. I'm pretty sure we have this exact same thing that we had before. Stream pointer. It should be, yeah. I mean, I could be screwing that up, I suppose. Well, now literally nothing works even with a device synchronized, so I broke something else. I'm honestly wondering the extent to which we even want Torch in here. It's so bad. I think I'm gonna have to content myself to like only partially be replacing Torch for this update, but like, holy hell, I don't understand. Stream pointer, I'm gonna have to check that in a second. Well, I actually don't even know how nothing works all of a sudden, because I'm pretty sure I didn't change anything. Oh no, it's past a diff. Stream pointer, where we get Torch streams. Let's do this the same way we were doing it before. So in capture graph, we do get stream, right? Get stream from pool. create threads. Nah. Huh? Just overwrites them. I think Claude's gonna be fired. Piece of shit. Still not stable. Yeah, we have to go back a whole bunch of code versions. This is just a complete unmitigated disaster. So let's try a couple things. This just drives me absolutely insane. Okay, so we're gonna do current stream is get current stream. are you setting this to? What? PufferL torch streams of I dot stream. I hate this so much. Is this even the right? It's torch C source CUDA stream. This has to be it. But then it says this thing has a dot stream, right? Torch stream, so CUDA stream. No, this is stream, not CUDA stream. Jesus. CUDA stream. Come on, GitHub, piss off. Okay, CUDA stream. And then they have a .h because of course they do. Unchecked. CUDA stream. So this is a actual stream, right? Give it the streams. I don't understand how this just randomly stopped working on like literally anything. So freaking frustrating, man. Why do the torch devs have to wrap literally everything they touch? They can't use a goddamn single thing from anywhere without adding 3 additional layers of bullshit minimum. Muon PR had their bot market as stale. Whatever. Their code sucks anyways. I'm sick of dealing with them. I'm like honestly just so frustrated with how bad this library is. I cannot believe that this is what we all use. And then some assholes ones they all use Jax, which is just even worse. It's like cutting your nose off to spite your face. You have net callback. Do I have net callback commented out? How? Did Opus do that or did I do that? Dude, I must have like autofilled that or something. Okay, well, thank you, Peru. I'm losing my mind here, apparently. Okay, this one works. Right? Yes. Good. And this one doesn't, unless it does all of a sudden. I did fix one other bug. And stream, not stream because it's not a pointer. Let me check that, hang on. Okay, so this is broken, confirmed. So you should pass. What does the net callback take? Is that actually, hang on. Did I just get void pointer diffed? No, it's still screwed up. Not used in the function, by the way. Hang on. I think I've just made a mess of this. I've just gotten so freaking confused. It's not used because... Yeah, because we're passing by buffer now. So you just need the buffer index anyways. Just take the void star out for stream. Streams of buffer. Is this good? Let's see. Yeah, but this still is not going to learn correctly. Yeah, no, this is not correct still. One thing I want to play with here. One thing I want to play with. These copies. Okay, so this does not break it, right? Which it shouldn't. We have the sinks in place. Can we try without photograph? Real quick. Just do this and this, right? Callback. After you copy the obs back async, shouldn't the callback wait before it runs the graph? Do the copy the... It's on the same stream though, right, Peru? Okay, so the non-graphed version works right here with no syncs. Sync on stream before you run the graph. If you queue something up that depends on an async copy finishing, won't it get queued correctly? I'll try that. I thought that gets my understanding was that if you queue an operation that affects, like if you queue an async copy and then you do another op that depends on the output, I thought it waits on ops from that stream to finish because it queues ops in this stream. I mean, that's easy enough to test. I just do queue to stream synchronize, right? Before the net callback. I don't think this is enough. Yeah, see, this is not enough. The copies are on the default stream. No, wait, the copy shouldn't be on the default stream. Because the copies are in the wrapper, man, right? The copies are in the wrapper, right here. I do need to do rollout copy call. These are all asynchronous copies. So these should go on the current graph. Set the same CUDA stream in the copy block. I mean in the call or in the for loop. You need to set where? The callback is around the entire thing, right? So it should be all the ops, including the copy, should be on the stream. The thing that calls the net wrapper callback. You need to set the CUDA stream in the copy block. I do. Stream. Stream, 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 right? This code currently works without graph turned on. I see, yeah. So if this code works without graphs turned on, It's not enough to synchronize. Hang on, let's double check one thing. I think you can't just synchronize the stream. I don't think it's enough to synchronize just the stream either. I think you have to synchronize the device, which is the problem. Yeah. If I synchronize the device, here it works. Meaning something's on the wrong bloody stream. Still. Syncing the stream should be enough. It would be if everything was on the correct stream. But as you can see very, very clearly here, if you put it on, if you sync the device here, it works. If you sync the stream, it doesn't. Right? So the question is, what the hell's on the wrong stream? We can go try, I suppose, one other thing, which is if I put this guy down here. I don't think that's enough either, though. No. Not enough. Something in the loop is on the wrong stream. Perfetto stream. Is there a reasonable way to set this up and like inside this entire thing? Try one thing real quick. So incredibly disappointing, man. Spending this amount of time on this crap. Nope. Not just the copy. I don't understand how the hell this is even possible. We have one buffer, right? This is actually in a thread. But we have one buffer for testing anyways. Right, yeah. It's not that. It's just like, I get trolled all day. is this thing? Peru, is there a reasonably quick way to do this or not really? With this, and this needs to be done. What happened to the amps? And the amps end, by the way, that was cool. Jess, I have no idea what the hell's wrong with the coup de graphs here. Like, I have absolutely no idea. I guess we can try for clues. We can go, this still works, right? Yeah, this one still works. What about kernel? Kernels breaks. Maybe nothing to do with coup de graphs. Try and do this. Oh. I see. What will this give us? This gives us, stream information, man? Thread local CUDA stream. Loaded. Okay, let me try. There's one other thing I want to try because it's actually breaking even without CUDA graphs, just with custom kernels, so I think that's a hint. Would have just been better to rewrite PyTorch. Jess, pretty damn much. Yeah, pretty damn much. Worth it? Okay. Let me use the restroom real quick. Let me try a couple things, and then if we don't solve it with that, I'll go back to this. So let me grab a new mug of tea as well. If anybody wants to look at this, like, the other sign that we have this is weird is, so our kernels all set, like, get current CUDA stream. I don't know if this op is, like, not thread safe or some weird crap. I'll talk to you in a bit. Yeah. I'll be back. I'm getting a new mug of tea. Technical edit torch. Dude, I swear. I don't need to have my own tensor library. I just need to not have this garbage. You know? Holy hell. Like, there's gotta just be like a no code written by idiots in any dependencies rule. Like, holy hell. It's like so freaking infuriating, I swear. If I were an idiot, how would I do this? I would have some operations that randomly use the default stream somehow, even though it shouldn't be possible. That's what I would do. I'd have some random stupid operation on the default stream, thereby screwing over anything else. That's what I would do. What hint do we have? Well, we have the hint that the kernels are putting something on the default stream, right? They would have to be. You know what? Why don't we just enable one kernel? We can just enable one kernel. Just enable one little kernel. Alright. Do it like this. And that one works, right? So then we do mingrew. Is it the gate? Figure out what is on the stupid kernel. Yes. If this one works, then there's only certain kernels. Screw it up. It's only certain kernels that screw it up. Very good. What about this one? This one has a backward pass to it. This one also doesn't seem to break anything. That's interesting. Okay. That's very interesting, yes? Please don't let me forget to undo this. Did I just do what I think I just did? Did I just type true or kernels like this and have it not compile and not notice? What does he have? Does it have that or? What? I'm shocked. I don't understand. Whatever. How about this? It's exhausting beyond belief. And we did actually compile, right? Yeah, this compiles. It's faster too, isn't it? Okay, that's not that one. This is going to drive me absolutely insane. This one should be safe. Just take forever to compile, Torch. Safe, cool. This is the one that breaks, really? The one that's not even in the callback? Really? Let's do that again. Okay, somehow the kernel that's not even part of this is breaking it. Get to current stream. You know, sit inside of a thread. Let me try something. what happens? No, not enough. Lovely. That's worse. Great. I don't even know how this is fucking possible at this point, man. I truly don't understand. Someone builds it. I'm not dealing with their crap, man. Their kernels we're optimizing have direct use in RL. Okay, so if you add a device synchronize here, then it still works with the kernels. What does that mean? Which means if I do, what is it, Vec? If I do this, it should also work, right? Does that make any sense? I think that tells us something. Yeah. Okay, so that's so weird, man. The network gets called. It's noise outside. Put something on the background quiet just to drown it out. Blood impulse. The only difference with the kernels, right? They queue on the current stream. Why would I do that? Why would I disable Ccache? Per buff stream per segment. So, Peru, right now I have one buffer for testing. I already isolated that. It's supposed to be per buffer. But there's one buffer. I wonder if this is a thread thing. Let me think about that. What if we go past it again? Saiho there. I actually don't know what he looks like, so probably. Because I only know his his picture from that. He was on Dota, right? So probably. God damn. I actually can't see what's wrong with this. I mean, you call... You set the current stream in the thread. Hang on, is this a problem? Actually, the kernels thing is not a problem, right? Let me try something. Come to think of it, like, this is totally fine, isn't it? Oh, wait, really? And maybe it's not fine. I thought I fixed this. Okay, I mean, we still then have the clue. Yeah, because this steps. So specifically, this kernel screws it up. That's bizarre. Okay. Almost if I just do this. Um, I mean, this is just completely insane. This one should work. Yeah, this one works, right? Yeah, of course this one works. Now we do. Damn it, man. Like, how? Does this not use? It uses the same frickin' data. Get current CUDA stream, right? Same as all of our other kernels. Let's just go double check something. Just give it the default stream. Convert environment. Ocean folder loans pre-trains. Wait. So the training code is just PufferLib, like PufferLib pufferl. The .c file is just for demo. The environment code is in the .h. Training is in PufferLib pufferl. Docs are at puffer.ai, the website. It'll walk you through. Well, at least I'm not going completely insane. It is a stream thing. Because if you set default streams, everything works. Right, and if I just do this, I do have it to get current, not default, right? No. It's always get current. Let's just make sure we're passing the right thing. I'm gonna go absolutely insane with this. This is just like, why? It's not it. Could stream T. This returns stream T. That be a ref. Oh. Wait. Yeah, no, this is fine. Yeah, damn it, no, this is fine. I should just print the streams everywhere. I just don't understand how this is so messed up. Nil is default stream. This is default stream. It's all correct. It's setting the stream correctly. We have all the clues. The fact that it doesn't work with a device sync with this custom kernel is really weird, right? Shouldn't that tell me something? What does that tell us, though? And wait, how the hell is that even possible, right? I think we should focus in on that. Right, because we have this thing here. This doesn't work, right? Yeah, that's broken. We have to find like some hypothesis that fits this, I think. Because I don't understand how this is possible. Like this one kernel. Yeah. So here's the question. How on earth does it work with everything except this kernel here? This kernel works fine without. On the default stream, this kernel works fine, so the ops are correct. Wait, what the heck even possibly fits this, right? Because the data that's coming into this has to be correct. Did I check the wrong one? CUDA stream T, get current CUDA stream. Stream gets passed. Get current CUDA stream. Stream gets passed. Does it get used? Launch. Forward. Stream. The only difference I can possibly see. Nope. This is on the current stream anyways. What? Huh? I have no words. Like, right? Wait, CUDA stream T. That's not what it is it? No, it is. Something is deeply fucked up. Internet. Rollouts impl OMP. Did you have any thoughts? CNN question? Suggest something? General to most better learning. I mean, the only thing I can suggest, Jess, is like our new network architecture probably scales better with more params, but it's hard to say. Like, I have to run the experiments. It's definitely default CUDA stream. I actually just have no idea remotely how on earth this is being like this. Okay, we'll try this. Very weird. Okay, so this still works. I swear if this is it. Actually just yeet torch. No. If I put it in train impl, Chess has worked with linear with value heads. Wait, what? Chess has worked linear. Super funky overparameter encoding with half. King centric. Square relative to king. That's weird. Wait, this doesn't work? I just have no idea at all. Oh, shit. Shit. I think I know. Fucking zeros. I bet the zeros op is not on the stream. Stockfish, one stockfish's neural net. They use the fact that it's mirrored and some other tricks to get super fast speeds. That's really weird. It's really weird, Jeff. I am just baffled right now. It's like bizarro. Okay, so I mean, this seems insane to me, but like, I I don't understand how there's something not synced. Forward train. Hmm. The policy is on a weird stream now. How? Hey Sam, organizing our Unix AI Summit. Want to do an online talk? Sure, I could do that. Crazy weird. I think that's what it has to be. It's some part of the policy. details and DMs. Sounds good. Yeah, I'm fighting Kuda, man. Today's been a rough. No, it's not only with coup de grace. Oh, what the hell are you? OX1. It's on OX1. How in the actual hell is this on a different stream? It is on a different stream. How? Is it variable? No, it's always OX1. It's OX1. I'm so freaking confused how this happens. This has gotta be what's happening everywhere, though. You know, it's just like sticking my stuff on a random stream. They're both one. We're gonna find this stupid bug. Why is default stream OX1? Unless I've just messed up. Do I have to do dot stream? No. Right? It's supposed to be CUDA stream T. So hefty. Puffer 5 is not going to be this size update. If I do something else this size again for the next update, I'm going to go insane. Okay, it is nil. Shit. Okay, so it's just nil. Drive me insane. Try this. See if it's synchronizing before this works. We'll isolate. I wonder if I'm launching the advantage on the wrong stream. That would be weird. I could see that. Okay, Joseph is confused. Where's advantage? Makes no sense. Oh, so I forgot something then. You dumbass. Okay. There's a rough combination of stuff going on here. Okay, so the hypothesis is still alive. Disadvantages. After the train. I could add a single device sync at the start of the loop, yeah. I will check that. That is reasonable to ask. Ooh, this breaks. See this breaks. So this is outside the loop. Let me try this and then I'll try your hypothesis. You very well could be right with that. No, it's not this. It's not the advantage function. This would do it, right? Because we don't use the other graphs, or we shouldn't be using the other graphs outside of this. Ooh. Good call. I think you're right. Yeah, I think you're right. Let's see. Yeah, I think you're right. Okay, so now we have this one on. Huh. Can we do CUDA graphs? We can do coup de grace. Can we do buffers? Alright, Peru. You've done... Yup. Yup. Thank you. I'm exhausted. I'm not thinking straight. You're totally right. I don't know how I didn't catch that. So... why is this slow? Do I have a bunch of sinks in here? I had the same problem as I did the native train. I don't know how I screwed that up, man. That was very dumb. I just kind of assumed I wouldn't screw that up. Like, that's nuts. Okay, you don't need these sinks in anymore. This is still good. It's 11.2. Where's our 11.8? You need this sink in? Whoops, no, we actually need this one. Actually, no, this one needs a device sink. Well, it doesn't. We need to do... Hang on. And then you don't need this, right? We synchronize the stream at the end. Batches in parallel within a horizon. We're doing that. That was the thing that got me the speed bump from you. Okay, this is good. I'm trying to figure out where our speed went, though. Because it was faster before. Yeah, that was the main thing I got from you, man, was that. Okay, so where did our perf go? Oh. I know. What the heck? 4. There. Yeah. That's 12 mil. Jeez. I'm gonna make a commit before I mess this up. I'm gonna rebuild just to make sure I didn't break it, just like fat fingering right there. And then we'll test this. We'll look for a couple extra sync points. We'll clean some stuff up. I need to walk around for a few minutes though. This is just like completely fried my brain. Thank you very much for that, Peru. I swear, when I've been live for 7 hours, I just start doing dumb stuff and missing things. Wait, didn't we have we had 11.8, didn't we? Oh, it was 12 mil. Right? It was 12 mil, I'm not. Yeah, my brain is fried. We're gonna do some easier stuff for a bit. I still need to put more work in today, but we're gonna do some easier stuff. Let me use the restroom real quick. Let me walk around. I'm gonna get a little bit more tea. I think I got a couple hours before dinner, so we're gonna do some stuff still. I'm gonna get a piece of toast as well, get a couple calories, and I'm gonna try not to be total goober for the rest of the day on this, because there's a lot of cleanup to do still. Ugh. I went and got myself a small sandwich. Hopefully, I will be less stupid. 11.9. Is drive any faster? If this runs. Slower. Lovely. We'll have to figure that. Oh, I might have it hard coded to a one map though, actually. That might be better than that. Let's see if synchronize the stream at the end. All these mem copies are async. Same stream. You know, we can probably just set the entire stream for this, like the stream for this entire call. Does Torch respect that? All these get and set stream calls. Yeah. What happens if we do it like this? How do you set the current queue to stream? Oh, is that a Torch thing? That's a Torch thing. Of course it's a Torch thing. Why would you have one of these? Yeah, that's annoying. Okay. It's a little faster than 11.8 right now. Let's see if I can just get rid of this overhead. And then we'll actually clean some stuff up. I just want to make sure we get a little bit of perf out of all this pain that we've gone through today. I'd like to just get a little bit of perf out of it, and at the very least, we'll know once I've done this that it's set. Yeah, you also have to have this thread init function, which is annoying, but whatever. I kind of figured it would do that. Because it needs to be a torch call, which is stupid, but whatever. Cool. Dude. Aw, that sucks. Yeah, that sucks. Whoops. Okay, so I mean, once we've done this, I think that's basically all the overhead we could possibly eat, right? Other than messing with OMP settings. Other than messing with OMP settings. So I have no idea if this is even any of the, if this has like any overhead addition whatsoever, but we'll do it. In it. Mm-hmm. Not a big deal. And then this one's not needed anymore. Yep. Okay. What are you switching gears to? Just, we got it. Peru found it. I was being stupid. Honestly. I'm trying to wake up and do some general cleanup. Well, we're doing this one last thing, and then I'm going to try to do some general cleanup. The hell? Eh. I forgot to update the SIG. Oh, nope, there it is. There's the SIG update. I was forgetting to think after updating the network. It was stupid. When are you hiring that man? Yeah, I know. I'm thinking about that. Like, what problems do I have? Exactly. Just give him some of the infrastructure problems. That'd be nice. Oops, not PufferLib. There's 12. Well, 11, 9, or 12. Alright, well, that's all the perf we're getting out of it here, so 12 mil. There might be some compile flags and things we can find, but I think that's... I mean, that's what we've got. Let's get our profile things back in here. This will not do anything. Oops. Yeah, this should not change a thing. Oop. Profile begin was not declared in scope. Yeah, this stuff needs to go down. Jesus. I'm like too tired to think. This is just going to the bottom. Too much domain randomization is bad. Okay, there we are. This runs. Quick commit. 12 mil, pretty much. I've seen it hit 12. Okay, well, this was supposed to happen like 5 hours ago, but we should now start cleaning things up. Right, we should start cleaning things up. Tons of things up. Some of this will be Claude, some of this will be by hand. Do we ditch multiple backends? I don't think we do. Try something. See if this runs. Okay, 480. Good. Oh yeah, Spencer, are you here? Like, if you're here, the drive end at some point would be nice to figure out. I can get it cleaned up though a little bit more, I think, before I ask you to look at it. But I want it, I want that to be one of our perf tests. We can show those folks some cool updates on 4.0. Okay, 4 buffers is fine. Is it ready for look at? I mean, you can look at it. There's still weird things in Puffer for sure. Ah, see, this is a pain. So why is our new backend slower for drive? That's what I was worried about. So 600. If I do this one to 2. About a 2x. New version 2048 is the go. Yeah, it's a pretty awesome end. Okay, 597. And then with this, which should be faster. We'll have to go test that. $450. What's the problem with the kernel? Fixed. Was stupid. Just missing a sync. Green light on when I can alpha test 4.0. Huge SPS wise. I wanted it to be today, man, but like I got stuck with the VEC and I'm still stuck. I fixed the threading. We got to do some perf stuff. Sadly, and some cleanup. And I'm not going to make you look at this mess until we know it's stable. Redone, rigsing terminals. Has anybody tried just resweeping that? Go is actually like, it's kind of like chess, and it's actually a pretty hard end. It looks easy, but it's not. To like, I mean to code fast. Both, Spencer, both will be faster for the drive end. Okay, so this is actually, as expected, this is faster. So why is training slower? That's weird, right? Especially at 1.24 mil. Google is taking, well, no. Not at all. Like, it'll be useful for stuff, but not for the stuff I'm doing. And it'll also just be hideously expensive, but, you know, unlimited Google money, whatever. I don't understand why this is, slower. Are they using different numbers of threads or something? No, right? I can't just perf optimize all day. I'm gonna have to clean stuff up. We just have to leave both backends in for now, but that's fine. Latest drive with new bindings. It is. It's in 4.0. I can commit the file right now because I have commented. Like, there's one map right now by default. I can uncomment the multi-maps if you want. I don't know what's easier to start with. Probably the current version. It's weird because it's actually, yeah, the vex speeds are a little different. It's weird. Binding.c. There are still a whole bunch of binding files. For now, they're just an extension slash endname.c. They're gonna probably get moved back to the original location and replace the original ones though at some point, depending on how we do stuff. So you had multi-map or single map. Right now it's single. You can literally just uncomment and rebuild. It's bash scripts build vec drive. There, like we have two options in there. I mean, if you can get the thing to just train on a map, like that would be cool. I just want to see what I screwed up. It's cool. I'm gonna have this thing do like the really coarse big refactors, I think, and then I'm gonna do the fine ones. Like, this is the moving shit around in 10 places variety. Be nicer. Yeah, one export. Gross. Yeah, super gross. Yeah, just a million tiny little things. Graph buff gets split. Let's build. The heck? Forgot to update the header, I think. Just update the header, and then this one. Next thing it'll be is splitting this. And then what else? These graphs, maybe. Quite a bit to do. Stream T type, fine. That's a little sketchy. I think that's a little sketchy. We'll see how that goes. The hell's it doing? No, that's not good. Okay, that's ass. Let me just see what's going on. So it's saying can it just not just use a bloody void star? Yes, better. I'm starting to feel that I'm getting lazy here, so I don't know. But there's still so much more work to do today. Oh no, you're not doing void star streams, you bastard. How did we have it before? Hey, Georgie. What in the hell? Put to stream T star. Where's this thing defined? Okay, we do have CUDA stream T. Fine. Fine. Now on this. We'll do the fine grain stuff after. 1%. There's neural networks, basic weight code, backprop. How do I train a basic 2 RL? You follow my guide. I have a very detailed guide on X. The article. This one right here. It'll sort you out. x.com/jsuarez. Shoot. Yeah, we're fighting a stupid thing. It's a very basic refactor, but apparently I shouldn't have even let this do that. So it goes and starts making void star. And we'll come back to this though. I just don't want this to do like coarse grouping refactor. So just like all the things where you have to change stuff in 10 places because it's very stupid at the moment. We're gonna get that down to be human editable, and then I'm gonna do all the fine grain. It's the goal. Okay, you know what? It's just so obnoxious. Why do you need that? It gets included, doesn't it? Wanted a pointer. This whole design is like garbage, alright? Like, I'm fighting with a few different things at the moment that are just like not letting me write good code. And eventually I'm just gonna have everything ripped out anyways, and it'll be nice. Like, this entire thing is just completely stupid. How is this so stupid? Like, we had this working before, right? It was literally just, this was like stupidly simple, no? Oh, this is the wrong one. Hang on. Yeah, so CUDA stream T. Where did I have this defined? I didn't? Oh, because it would just get included. Hmm. Purchase 3090. Relocation against Vec render. Okay, let's go. What on earth did it do? Yeah, what the hell? No, this whole thing is stupid. I hate everything about this design. Now C++ and C. This is such garbage. Yeah, these don't need type defs. No, this is just garbage. This is so bad. No need to cast in C. I really, really do not like this. What gives us? It's whatever the hell version of C++ Torch uses. I might honestly not want it to be a shared library. This is so bad. But if I link this static, it's very, very annoying to me. Do we need all these type defs? Let's fix this first. I think what we're gonna end up doing. How bad this looks. If I link it static, I don't know how you include. There's not a reasonable way to train many different environments that I can think of if I do it static. Like, you'd have to edit the source file every time. That's actually not bad, is it? Man. If it was shared, it'd been fixed mode. I mean, at least you don't have macro hell with a shared library. Like, what the hell is this? I do not want this in my code base. PyTorch and C. It's a C shared library to be loaded in PyTorch. PyTorch C++ specifically. It's better. This one's a mess, but we can just refactor that. See, I wanted to do this fresh today while I was fresh, but like I just can't think about this. I think we're gonna go to the main file and try to do some stuff there for a little bit before dinner. And I'll see if I maybe get a little bit of energy back afterwards. This shared library crap just sucks. It's just really not good. I grind plenty. See if you can re-implement self-play. Not today, Jess. Not today. Where's her frickin' perf, man? That takes 500k SPS off, really? We have stuff going on in the background? No, man, we're just not dealing with that. We're not gonna deal with that. hidden expansion. Actions. There's there. Patch all these stupid warnings. Claude and then Mac. I don't keep up with this crap. I don't know. Whatever. Yappity yappity yappity. Whatever people do on Twitter. Weather compilation. I don't want to disable. Good. Yeah. Okay. It's better. License. It's fine. Cool. I love how Python makes breaking changes to their packaging of all things constantly. The impulse force binding. Don't see anything there as a problem. Okay, that's fine. No. Let's not do that. Suppress. That did not do it. Filter warnings is kind of bad anyways. We'll just leave this one. Stupid torch. Okay, so cool, that's decent. Dash G. Why do we have dash G? This. Sometimes O2 is bad. Just not any faster. For sure. We can leave that alone. W sign compare. Does it have performance overhead? P does. I don't know about dash G. Debug simple table. Okay, no, that's fine. I was thinking of dash P. Okay, this is fine. Diving into skills. No. The model is very stupid no matter what you do with it. It's honestly kind of gross I'm using it as much as I am already. The only thing I can say is, like, Torch is awful, and everything is super verbose. So, like, whenever I need to edit something, I have to edit something in a bajillion places. So my hope is that I can get this into a format where I don't have to be using the models as much as I am now. And I can just, like, cut out a good chunk of this redundant crap. Because it's really bad right now. Like you see the cascading effect here. It's just like the way that Torch is. It's actually, this isn't even that bad. The kernel stuff is way worse. Because you have to cascade through the additional Torch modules layer. It's a pain. But this is basically, these types of ops are basically like IDE refactors, barely more. I still don't like how this is. I'm gonna have to think about the shared library stuff as well. I'm not happy with the shared library stuff one bit. Stupid models. Okay, this will be better. 4 buffers. Not bad. I can have it move stuff around. Pretty easily. Okay. Create function for these. That's weird. I'm a little sketched by that. That might be Ccache being weird. Oh, I see. That's fine. Okay, we're fine here. easy. That's better. These are now nicely grouped. I think I can do a lot of the moving around manually. It'll be quicker than even having this do it. Namespace PufferLib. Top. Failed to import. This has to go under namespace, doesn't it? Yeah, it's just a stupid name spacing. Environments. And we have all these. Does this need to be here? No, it doesn't, right? This can go down. Actually, a lot of this stuff can go down lower. I like having the data structs near the top. And we have hypers. PufferL. Okay, it just goes in the namespace. Fine. Okay, we still have 1,000 lines of code here, which is ridiculous. Let's see what we can do. The impulse will have to stay for, like, the couple different impulse will have to stay for the time being. Oh, it's this create impulse is huge, right? Okay. Nutty. It's very nutty. Capture graph. There's tons and tons and tons of crap here. Initial state impl. This can get exported from I think we just start like tagging shit for Claude. Works. Probably alias a couple other things. Log environments impl. I see. We're gonna need these losses. Not yet though. super screwy. It's a good starting point. I don't have a good way around this for now. This might just be the answer, honestly. We just add a big binding file or whatever. Not have everything be stupid shared objects. What's this? Create threads. Let's see. So much stuff, man. So much stuff. It's a good first pass. A couple small things. I like doing this sometimes because it keeps me more looking at the code and rather than just typing shit into Claude. Ridiculous, yeah. 180 million bucks of food and rent, I'm sure. No, it's not. This thing's really stupid, man. This thing is really, really stupid. I think it's slightly smarter than the meta engineers, though. So, we'll have the very stupid language model clean up the mess made by the incredibly stupid meta engineers, and then I'll end up cleaning it up myself from there to make something very nice. That's probably what'll end up happening. Fine for now. They're paid like 600K. Lo and behold, your salary is not very well correlated with whether you're worth a damn. Lo and behold. Read any of the PyTorch source code and tell me I'm wrong. Good luck with it. See you around, man. Null pointer, null pointer. It's so freaking bad, man. This is still so bad. Honestly, I think I should just put in some effort to figure out how to get this stupid thing to compile faster. Yeah, like this, right? Let me make sure it did it right. Yes. This is what I meant. It just hurts to look at. It really does. What's this? Strip a little bit from this. Yeah. For refactor. Being unmagnetic. It's not commie at all. It's literally just that the managers are also pretty dumb. I mean, this just happens at every big company, right? The companies try to grow very quickly, they get big and they lose talent density and they end up wasting a bunch of money. Anybody that has worked at a big company that does not pride themselves on it will tell you the exact same thing. Like, a lot of what these big companies produce is just hideously stupid. This goes down here. Create. This is not used. Antagonistic. You can. It's like OpenAI did for several years. You just can't grow super fast. That's literally all it is. Like, basically, as soon as you take a huge amount of investment and have pressure to do stuff super quick, like, that's it, you're done. Like, you'll go make a bunch of money, sure, but you're not going to have the same level of precision and clarity about everything, right? And produce these, like, nice, very understandable artifacts that smaller companies will. There's just a lot of bloat. Love to get in if I were paid that much. Meh. I mean, it depends, right? When you've literally spent half of your life on this stuff, like really, really getting good at something, it's like the offer is no longer tempting at all. Like working at one of those big companies is basically the most depressing shit I can imagine. Like as for the work itself, like I have done like growing up, I have done manual labor jobs that were more enjoyable than some tech internships. It's just like god awful soulless work. You have to risk your life, but still, that one's a pretty tough sell on that. Fair, Jess. Fair. Num buffers, total agents, like, what is this crap, right? Beck is supposed to have this. Everything is just super freaking confused. When will you be back, Maryland? Probably a couple months. I do miss it. It's just friggin' cold right now. Got a little code. Little bit. Hey, this is the Great Olm fight. This is the fight that I was using for the environment when I did that stupid vibe coding stream. The agent figured out how to do this exact thing basically instantly. I didn't do the gear switching in the sim though. But this like exact running pattern where you take 0 damage, it's like an exploit of the way that the boss turns its head. This guy's doing it the super sweaty way to show off for no reason, to be fair. There you go. And you said you did not want to download the game? Look, alright? I earned a bit of a break. And X has been awful, so I don't even want to be spending my time, like, posting stuff for, you know, Viz and advertising on X. It's just been gross lately. So I've been chilling. I've been just doing this dev and chilling. It's just a stupidly good game. What happened to rollout copy inputs? No, Jess, there's no skill involved with it. Like, I could use it more minimally, I suppose, but honestly, for ends, I really think that it's better to mostly code them myself. Now, if I were to if I were to use this for something like that, it would be for a port. So if I were using this for a port of existing code, for instance, there's this TypeScript, the shitty TypeScript sim of some of the RuneScape fights. That I could do, but from scratch, I think I would probably still just write it. That's fine. Shitty, just easy graph code. We'll merge some graphs after. I think these are all just going to end up getting mostly merged anyways. Yep, this one's good. I think I'm gonna have to do a bit more work after dinner, depending how I feel. There's just so much more to get done here. Let's make it shorter. Same length. Okay, that's not bad. Oops. Hang on, guys. Ah, damn it. Dinner? Gotcha. Yep. Alright. I gotta go in 5 minutes for dinner. Streaming Friday? No. Friday? Well, I might stream a bit. We will see. I'm not gonna do the full day though. I don't know if I'm gonna go running just outside or if I'm gonna go back to the gym. I definitely need to get my exercise though, for the week. Saturday all day. I wonder if you can just graph this entire thing. We could probably get it to try doing that. I don't know if that would be better or not though. We could probably save some redundant copies actually. Yeah. I got some ideas on how we can speed some stuff up still. There's still some free perf on the table. Okay, still 11 mil. We definitely, we lost some perf, but I know what we lost it on, don't worry. We lost it on the stupid shared libraries. That's the other thing I gotta think about. So there are a couple bigger things for the refactor that I think will get us perf back as well. I was gonna say this file is getting almost tolerable, but it's really not yet. There are a few projects. There are a few like bigger refactors I'll try Claude with, and I think once we have like the final design of everything set and all the enhancements, I think the rest of it will just be by hand. Because otherwise I get lazy. Well, I gotta go anyways, but I will, let me commit this real quick. Then I gotta go get dinner. Whoops. Okay. I'm gonna go get some food. Depending how I feel, I might stream a bit after dinner. We shall see. Thank you, folks, for tuning in regardless. If you're interested in my stuff generally and you'd like to support my work for absolutely free, feed the Puffer star on GitHub. Helps out a lot. Join Discord to get involved with dev. We've got a lot of people in here. Started off pretty new and are now very, very talented. And follow me on X for more RL content. Probably back after dinner.